So now we're going to talk about another type of transformation, specifically a composite transformation. Now, composite transformation is pretty straightforward, and it actually looks like something like this. So if I took this triangle and I were to reflect it, so I'm going to do a reflection, and I'm going to reflect it over the y-axis here, and I'm going to reflect that object and apply that. So then what I'm going to do is I'm going to define another so let's just do some quick labeling here. We now know that this is A prime, this is B prime, and this is C prime, right? So now what we're going to do is we're going to define another transformation, a translation specifically, and we're going to choose, let's say, down a bit and then over a bit. So we'll start at this point and we'll go over. So we'll go like down 4 and then over, how about 5, just like that, right? And we'll do this to this object. So what does that do? Well, it takes the object and simply put, we know a translation just moves it in that along this vector, right? So down a certain amount and over a certain amount. Now, because we've transformed this once, A prime, B prime, C prime, we've taken what is the transformation and then transformed it again, which means that now this is the result of 2 transformations. So we will use A double prime, B double prime, and C double prime. Now, if we felt like it, could we do another transformation? Sure, we could even define another transformation if we wanted. Let's say we're going to do a reflection, and let's choose a line of reflection, which will reflect it over the line. Oh, let's go this one, the x-axis, and we'll apply it to this one. So then if we apply reflection number 2, it reflects over there. Now this is a little bit overlapping because, well, it's a little bit overlapping, but it does mean that when we're looking at this, this point here is actually a triple prime also, right? Because we reflected it and it was on the axis, B triple prime, and then C triple prime. So we have a series of a reflection over the line x equals 0, a translation that ended up being down 4 and back, or sorry, positive 5, so that's a positive 5, negative 4. And then the last one was a reflection over the line y equals 0. All 3 in a row. That's what a composite transformation is. A composite, like a composite word, like a compound word, is made up of more than one word. A composite transformation is made up of more than one transformation. So it's a set of transformations, one after the other, to a point or set of points. Any set of 2 or more transformations is called a composite transformation. So it takes 2, think about it. In order to be composite, it has to be 2. We use the same terms, pre-image and image, but the number of primes, as we saw, increases. So 1 transformation, 1 prime. 2 transformations, the image ends up getting 2 primes, and so on. So there are 2 types of notation used. So the transformation that we did on those so we did some transformations to triangle A, B, C, right? Which represented those points. The first thing we did was a reflection over the line y equals 0, and then we did a translation that was over 5 and down 4, and then we did a reflection over the line x equals 0. So this thing right here is read as composed with. So this is a reflection composed with a translation composed with another reflection. Now please notice the order. The thing that we did first was this, second, and then third. So this is what we call composition notation, because this is a composed with symbol. It's an open circle, all right? It's not an O or anything like that. It means composed with. The other way to read this is follows. You could also think of this as follows. So this would be read as a reflection over x equals 0 follows a translation over 5, negative 4 follows a reflection over line y equals 0, which means that this will come first, second, and then third. The key thing is whatever is closest comes first. So this is, so for instance, if I were to write a reflection over y equals x composed with a rotation of 90 degrees, which I could do, and let's say I'm doing it to the point 3, 4, then the first thing I would do would be the rotation of 90 degrees. So the rotation of 90 degrees on 3, 4 would be opposite y, x. And then once I've done that, I've taken care of that. So then all that remains is to a reflection over line y equals 0 on that. So that's just more like what we have already seen before because it's a singular transformation. Y equals 0, remember, is the x-axis, so the x will stay the same and the y. So then the result of this, that is, after we do both of these, the result is -4, -3, okay? So this is one way of doing this notation. Here is another way. An alternate way of doing this is to use a series of parentheses. So I'm going to do an R90, 2, 3, 4, right? And then I'm going to do a reflection over y equals 0. Please note, now it's kind of hard to tell, but inside our first set of parentheses is just a point, nothing to do. Inside the second set of parentheses, right here is here and here, we do the R90. So you think like order of operations, you do the innermost set of parentheses, and then the last thing we do would be this reflection. So this and this mean the same thing, okay? So like up here, and it can get a bit messy, get lots of parentheses if you want, triangle ABC, right? I'm going to do that to triangle ABC. And then I'm going to do the translation, and then I'm going to do the reflection over x equals 0, just like that, okay? It still works out the case that you're going to do the thing that's closest first, next closest, and so on. You're working your way out when you're doing this in terms of the order, okay? Either way, either way you do the notation. So here are a couple of examples. The thing I would do first here would be the rotation of -180, and then an S-2, a dilation scale factor -2. So going step by step, a rotation of -180 is the same as rotation of 180. All that does is change the sign. So when I do that, I end up with that. Then I do an S of -2, so I multiply by -2. And then that would be my final answer, the double prime, if you will. Same thing here, different notation, but I'm still going to closest thing. So reflection over y equals 0, reflection over the x-axis would become 2, 1. And then I do an R90, which is opposite y, x. So this becomes -1, 2, just like that. And here's a 3 first. So you just want to basically show all your steps so you don't mess something up. So you do your rotation of 90, which is opposite y, x. Then you do a reflection over y equals opposite x, right? Technically, we still have this left to do, so let's just write it down so we don't forget. So reflection over y equals opposite x changes the sign and changes the order. And then we do a translation of -5, -6, which means we subtract 5 from the x, and we subtract 6 from the y, which means that this would be -13, -18, all is said and done. Remember, 1, then 2, then 3. And you're doing it to the resultant because this means that if like this were a, then after this it'd be a prime, and after this it'd be a double prime, and this would be a triple prime, okay? Now, an important thing to remember is sometimes the order in which you do a composite transformation makes a difference, or does not make a difference. Sometimes it does. Don't assume anything. In other words, take a look at the examples. So here are a couple of examples. Here I would do the translation 3, 4 first, then the rotation 90. What does that mean? Translation of 3, 4 would be 6, 0. Then I do R90 to that, and that would become opposite y, x. So this would be 0, 6. Look at this. Same transformations, different order. So what does that mean? Rotation 90 would be opposite y, x. Then the translation of 3, 4, that's a 4, would be 7, 7. So that means that this becomes 7, 7. Now please note, these are different, so the order makes a difference in which you do this. All right. A couple of more examples. First, reflection over y equals 0, aka the x-axis, meaning 3, 4, right? Then a reflection over y equals x, which would be 4, 3, right? Practice, practice, practice. That's how this works, right? Here we do a reflection over y equals x, so this becomes negative 4, 3. All they do is change places. Then we do a reflection over y equals 0, so we reflect over the x-axis, and so that's negative 4, negative 3. So either way you slice it, we end up with something a little bit different, right? So don't worry about whether the order or not makes a difference, just assume it will be different, meaning you have to actually do this out to figure out if something is going to be, what the result of the composite transformation is going to be.